All right, let's move on to our next biomolecule, our carbohydrate. Carbs and carbohydrates, they're talked a lot about. It's a big buzzword in the diet community. So let's talk about what they really are and what purpose they serve and why they're not the absolute most terrible thing, and what they're actually used for. Okay? All right. So here I have that carbohydrates are sugars and substances that hydrolyze to yield. And I know this is real small, but here I have the definition of hydrolysis. Hydrolysis is the breaking of a bond by adding a water molecule. Okay? Hydro, I'm sure you guys have probably figured this out. Hydro means water. And lysis here refers to breaking apart. Okay? So when we say hydrolysis, we're literally talking about using water to break something apart. And that doesn't mean physically. It's not like shooting something with a pressure washer. It's just the addition of a water molecule that will allow for the breaking apart of other molecules, and in this case it yields sugars. Now it also is worth noting that carbohydrates, it says here, are sugars and substances that hydrolyze to yield sugars. So substances that hydrolyze to yield sugars, that right here is typically what we refer to as, oh goodness, I skipped a letter, STARCHEEF. No, switch pages on me. Hold on, let me try again. Starches is what I'm trying to get to. Let's see if I can get it all to fit on this line. All right. STARCHES. Ooh, I got it. All right. So starches. These are compounds that break down to yield sugars. All right. So here, underneath, we have some examples of naming conventions for these. Saccharides would be the sugars that they break down into. Okay, so we have here monosaccharides. Mono means one. We have disaccharides. Di means two, also like bi from the last time we spoke. And we have poly, we've talked about that, that means many. All right, so let's go a little bit more in depth. Monosaccharides, example, glucose. Glucose is a huge thing for our body. When you use up, when you use up any sort of energy, a lot of those energy stores actually come from glucose. It says here, glucose is a sugar found widely in nature. Starch and cellulose are both made of hundreds of linked glucose molecules. Glucose is the most common organic molecule in the world because it is found in all plants. But wait, all plants aren't sweet when we break them down and eat them, right? So let's talk about why they're found in all plants. It's because of the way the plants make their food, or photosynthesis. Okay, photo here meaning light, synthesis meaning creation or formation. All right, and it's because we know that they use light to make their own food, right? And so this is what this process is called. Now, when they do this, okay, y'all be patient with me because I'm going to try and fit this into this page. Okay, so the process of photosynthesis means they take CO2 and water. Oops. Water. And they convert it to glucose, and oxygen. Okay? I'll put my 602 there just to make sure it's balanced. So we have the traditional thing that you're taught, in life sciences as you're growing up, that they take in the carbon dioxide, they take in water from the ground, and then they use it to make sugars to fuel their own cell processes and also release oxygen for us to breathe. That's why we need plants and trees around, because they serve to keep putting levels of oxygen back into our environment, which obviously is very helpful for us. Okay. So another name for a monosaccharide here is a simple sugar. Okay? And when we say simple, we mean that it's very, very simple to break down. Okay? It does not mean that it does not look complicated if you draw it out structurally. It just means that it doesn't require quite as much effort to actually break it down. Excuse me. It does not require quite as much effort to actually break it down. Okay? So let's see. I believe I've got a good picture to show you guys on this next page. I'm trying to flip through my other notes, make sure I don't miss anything. Yeah, so let's go ahead and flip to the next page and let's look at this. Okay, so this right here, these are different structural diagrams that are used. We've talked about structural diagrams. It tells you exactly how the things are set up. The atoms are set up within the molecule. It tells you how it's liable to react or not react, as the case may be. And so what we have here is we have where it kind of connects, and it makes sort of a ring here, where the ring of the carbon atoms here, and one of them, of course, is an oxygen atom. So this right here is just glucose. Okay, all three of these forms are glucose. It's showing where the straight chain form will go into a more of a cyclic form. Okay. Also, it's worth stating that down here, now we've swapped over to a disaccharide. Remember, di means two. So here we have alpha glucose and beta fructose. Alpha and beta here meaning just 1 and 2. So these two sugars together form sucrose. Sucrose is a disaccharide, and this is just table sugar. It says it up here in here, table sugar, right here. And so this is like, okay, if you were cooking with or making sweet tea or something like that, and you go and you scoop some sugar into whatever it is you're making, this is sucrose. Okay. Now, let's talk about another. Let me switch the. Nope, we're not there yet. Let's talk about a couple more. I got one more disaccharide, and that is lactose. Lactose. I'm sure you guys have heard this as well. Lactose is the sugar, the principal disaccharide, the principal sugar that is found in milk. Okay? Oh, sorry. Hold on, my tablet's going crazy. All right. Yes, so it is the lactose is the sugar that's found in milk. Okay? So it is 1 glucose and then plus 1 galactose. And so those are the two that make up that particular disaccharide. Okay, so here we go again. Next page, polysaccharide. Okay, polysaccharide. Now, poly meaning many, so many of these saccharide groups form together. Specifically, it says here many, but specifically we're talking about 3+ groups. Okay. So we don't have trisaccharides. Anything 3 or more becomes a polysaccharide. Okay, so let's talk about 3 examples. Here it says starch and cellulose and glycogen I'm going to talk about as well. Okay, that's not clear. Try that again. Glycogen. All right, so starch. When do we deal with starch? Starch is made up of 200 to 3,000 glucose units. Glucose is joined with all molecules in branch chain pattern with all the glucose rings in the same orientation. What? Okay, so what that basically means is we've got like a chicken wire effect kind of going on with starch, where you have a ring and it's connected by a chain to the next ring, and then it's connected by a chain to the next ring. Okay? So this is the structure of how these saccharides are getting together. Starch is mostly found in roots. Okay, seeds and roots. Seeds and roots. Okay, so for here, that's talking about potatoes. Potatoes are a root vegetable. They are a starch. We're also talking about corn, rice, wheat. Okay, these are starches that we kind of interact with commonly. Oh no, I went off the screen. I'm sorry. Let me try that again. Okay, let me see what's up there. Corn, rice. Okay, so let me try that one more time. Okay, so next to corn and rice, I'm going to rewrite potatoes. I'm going to rewrite wheat. Aha, okay. So, those are where we normally interact with those. So let's talk about cellulose. Cellulose. So cellulose is mostly found in stems. Okay? So we have stems of vegetables, but we also have just wood in general. So like tree trunks and things like that. Okay? Now, I think this is interesting here. The paragraph right underneath it, it says, unlike cows, horses, sheep, etc., humans cannot digest cellulose because we lack the enzymes necessary for this chemical reaction. Okay? So, a lot of people will try and make the argument that being a vegetarian is like, eating grass or something like that, or eating rabbit food, right? But the truth is that we really couldn't handle such a diet. We do not have the ability to break this particular carbohydrate down. So, I do not recommend grass as a snack if you get hungry. All right. All right. So let's talk one more time here. Let's talk about glycogen. Okay, glycogen is the main way that polysaccharides are stored. So we're storing polysaccharides. Now, why is that important? Well, because we've talked about this before. Saccharides. Let me see if that all went on the screen. Yes, there it goes. Okay, so why do we need to do this? Well, because we can't constantly eat just enough for our, next few interactions or our next few movements. We don't know what those are going to be. So our body is set up to, when we have food, to use some of it and to store, to store some of that energy for use later, since we don't always know when things are going to happen to us. Okay? So we need to store these polysaccharides in case we need to go back and break some of them down for energy. It's the same thing with fat, okay? We need to store some so that we have sort of a backup in case we really get into a situation where we're not able to eat for a little while. Now, glycogen is pretty much stored in the liver and in our muscles. So when glucose is needed for energy, when we need these polysaccharides broken down into glucose for us to use, then we have the ability to, our body directs our liver or our muscles to give up these glycogen molecules, and they can be broken down from polysaccharides into monosaccharides like glucose that can then be used to power our body's movements and reactions. Okay? All right, I think that is just about it. Yep, that is it. All right. So I will wrap this up and I will make the Google form questions for you and get this posted. Have a nice day.